Wow. Okay, so part 1 of this video from back in May, Calculus Student versus Math Difficulty Chart Obby, did insanely well. It's at over 300,000 views now and is my best performing video ever and has claimed the title of my most viewed video. It also skyrocketed my channel from like 5,500 subscribers to over 8,000 now, so thank you everyone so much. The obvious thing to do now is make a part 2. I worry I might have waited a bit too long to making this part 2, but well, that's what the college credit grind is all about. For just the same reason that I took calculus in the spring, I took some classes this summer, which they're done now, but that took just all my time. So that's why I posted hardly any videos in like June. But we're back at it now. So where we left off last time, obviously not out of my difficulty now, but it will take many attempts to, get each stage. I mean, this is only like my second attempt at this one, and this is only like my second at this one, and yet I've done it. Okay. What is the sum of the reciprocals of the roots of that? This was a question we got to that I wasn't sure how to do because I don't remember learning it. But as I only have 5 stages left, I guess I should be trying to figure these things out. So what is a reciprocal of a root? Desmos Scientific Calculator, my beloved. Alright, what Google is claiming is that the reciprocal of a polynomial function is that you just switch the first and last coefficients. That is, if you have it in standard form, so like decreasing order of the exponents, like 3, 2, 1, 0. And then does this mean if I go to Desmos Graphing Calculator, my beloved, if I graph this new one, does that... There's only one root. I don't understand this. But we also have that if we graph the original one, then whatever its root is, so this is the root of the original one, this is 1 over that. So that means 1 over minus 0.1 is, in theory, that. No. Well, we could always just guess and hope I get it right. Wow, okay, sure. Boing. Wow, okay, that's really smart. Come on, there's only 5 stages left. Surely this won't take me all day. And actually, you're not going to believe this. I'm recording this in the middle of the day. Like, not at 2 a.m. Also, America Ra. Did I do that wrong? No, I think I can jump up there. That was sketchy. I feel like I couldn't make that, but I just did it twice, so okay. Pop.mp3. Please don't do something sketchy. There we go. As in, make me walk backwards off the truss instead of climb down the truss. You know you were planning to game. Okay, so these things are gonna launch me. What if I just, okay. Okay, so just jump at the appropriate time. Nice. Again, this started being the case on, the previous... please let me... Okay, there we go. It started being the case on, the previous grade. These stages are really long, so if I get the question wrong, there are real consequences. Am I supposed to wrap around this? Is this ice? No, that's just glass for... Yeah, that's glass, not ice. Okay, that wasn't so bad, actually. Reading the literal thousands of comments on the... I think it was thousands. Hold on. No, okay, hundreds of comments, thousands of likes on that video. Wait, what? Apparently I had an insta-kill. Great, okay. As I was saying, reading the literal hundreds of comments on the previous video, what seems to be the struggle for many of you is not the math, but the obby. Okay, more math. In the binomial expansion of, oh boy, what is the coefficient of the term that? Easiest thing to do is search what is binomial expansion. Alright, so I've done some research on what you're supposed to do. So you need to basically, we can start like this, and then we want to write, wait, hold on. We need 5 of these. We want to do 1, 4, 6, 4, 1. So we'd have minus 48x cubed y1. So minus 48 is, in theory, the answer. What? Alright, I've discovered that binomial expansion is actually just a faster way of multiplying this out. So, it would be faster than just going, 3, 4, 5. Then multiplying all that out, that would take forever. But seeing as how the other way didn't seem to work... Alright, that took forever. I really hope I got it right. What is the coefficient of x4, y1? That would be this one here, and it's negative 10. Oh, finally. That was all worth it in the end. Alright. I can take a break from the math and do some obbying. It says hold jump, okay? Jump towards the back of it. There we go. Okay, I need to jump towards the back of the launcher thingy. Okay, here. Okay, wait for it to come spin around, or could I get in like this? No. Okay, that was not smart. Now I have to do this again. But now that I figured out the consistent strat, it's fine. Let me stand on top of this thing and then just time that right. Okay, and then I guess the launcher sort of holds me in place. Now what? I want to jump out at the right time. Nice. I'm gonna jump at an angle and wrap around accordingly. What? I pressed jump, That teleports me somewhere, right? Isn't there supposed to be a beam telling me where it teleports me? Maybe not. What does that thing do? Is it like a... Oh, wait. That teleports me there, I guess. I can test that theory by kind of going like that. Yeah. It's gonna be risky. Like, I'm gonna have to just commit to it. Yeah. All right. So I gotta turn a bit more. That's fine. There we go. This conveyor is strange. Well, that's helpful. Ah, it's icy, I guess. Okay. Could I high jump that? How many studs is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Nah, can't high jump it. Could lag high jump it, but I won't do that. Okay, maybe I should have. I don't even know how to lag high jump. There we go. Oh yeah, I've got a lot left to do. I'm not even anywhere near done with this. Let's see what's going on here. Yeah, we had some stuff like this before. Yeah, that was close. I didn't like that. Well, I need to make sure I land over here. There we go. There we go, finally. Okay, and then that's it. There's the end, unless I get this wrong. What is the radius of the sphere represented by the equation? Bleh. Oh boy. All right. From this, I can clear that now. Well, I know that this is the equation of a circle, where h comma k is the coordinates of the center of the circle, and this is the radius of the circle. So I guess that on a 3D coordinate plane for the equation of a sphere, it would look pretty similar. Yes, I was right. This is the equation of a sphere. So here's what they gave in the problem. So if I can get this to look like this, then I can have that. So let's start by just putting the like letters next to each other. So we'll do y squared minus 8y and then plus x. Wait, it's supposed to be z squared, isn't it? Then factor each one. Well, I can factor out the letter from each one, so I can do like x minus 4, because if you multiply that back out, it'd be x squared minus 4x. Yep. Then plus y minus 8. But that's not really what this is looking like. Guys, you're not going to believe this. Desmos has a 3D graphing calculator. Wow. How have I not known about this all this time? Well, since I can't seem to figure this out, you know what that means. If I just paste that in, then all we got to do is find the radius. There we go. If I zoom out, now I can see the whole sphere. If I kind of center this at the top, or get it to the top there, you can see it goes... So if I put my view kind of above it, now I can see how many spaces across it is. 8, 9, 10, 11, 12. So 12 is the diameter. Half of that would be 6. Nice. A little bit cheaty, but... So this stage kind of looks like a tower, like is at the end of all the stages, or all the grids, I should say. But like they're multiples of 10 that are like that. This is not a multiple of 10. Okay, that's going to be an annoying jump. Oh wait, no wonder that would be annoying, because that's wrong. I'm supposed to go this way, and I guess jump to that teleporter. Hopefully it doesn't do anything weird. No, okay. Hold jump again. All right, I'm going to try jumping towards the back, and then hope I just kind of, yeah, I don't really have to turn my camera except kind of on this last stretch if I'm way off to the side, which I probably will be if I line it up for that. That's not even the end of the stage. I mean, it's kind of close. Probably gonna fall on the way there though, especially because we got a funny ladder incoming. Do I even have to go into climbing animation? Because I don't want to, because it's gonna do something stupid. This is gonna be annoying, I can already tell, because it's gonna do that. So I want to instead wrap around. There we go. Fate avoided for the moment. We'll see about when the math comes around. /e shear, and that will, I assume, hit the teleporter. Yes. A box is being pulled in 2 directions with the forces of 8 newtons and 2 newtons separated by an angle of 120 degrees. What is the resultant force acting on the box? Well, I'm glad I took physics last semester. Unfortunately, we didn't really deal with vectors at different angles. Like, we talked about it briefly, but said, I'm not going to ask you a question about this because they're really annoying. I think what I can do is break this into its, like, break each vector into its component. So what I'm going to do to make my life easier is make the 8 newtons one be straight, like horizontal, and then the 2 newton one be a bit more than 90 degrees, so that would be like here. I'm actually going to draw the 2 newton one super long. Well, I'll adjust this one accordingly. That way I can draw, like, well, you'll see, just so I can have more space. So we break this one into its horizontal and vertical components, and technically we do that one too, but this has no vertical distance. Okay, we'll say this is 0 degrees, this is 90 degrees, so that would make this be 120 degrees. To find out the newtons of these 2 directions, I'm going to need to know, like, these angles. So if this is 120 degrees, then this would be 180 minus 120, which would be 60. And then we have 90, 60, 30, I guess. Wait, what are triangles supposed to add to? 180, right? So we have the angle measures, and this is 2, so then I can use trigonometry to find these other ones. So if I'm looking for this one, I can say sine of 60 equals opposite, so x over hypotenuse, which would be 2. So sine 60 equals x over 2, so I can multiply this by 2. So what is 2 sine 60? That. So 1.73 newtons at 90 degrees. But then we can also find this one, which would be cosine 60 equals adjacent over 2. So 2 cosine 60 is 1. Okay, that's convenient. Well, if we have 1 newton here, that means we got 7 newtons at 0 degrees if we add this and this. If we had 0 and 1.73, we got 1.73 newtons at 90 degrees. Because it's just 1.73 plus, well, 0. So now if I redraw this, 7 newtons this way, 1.73 newtons this way, then all I need to do is just find this. So this is 7, this is 1.73. All I need to do is Pythagorean theorem, which would be a squared plus b squared equals c squared. 7.21. Now they wanted the answer in like square roots. So what I can do is just do 2 square root 17 and just 2 square root 13. So which of these is basically the same as this one? It would be this one, which in theory means the answer is 2 square root 13. Nice. All right, 2 stages left. Oh boy. Sight read before you go. Well, I can just go for it because like it's the start of here, so what does it matter if I fall? This ain't floor 10 of a tower where I should definitely look ahead. No, no, no! Oh, this is cool. I like that. Okay, so I just gotta jump at the appropriate times. Okay, yeah, it'll take a few attempts, but I'll get it. There we go. The next sections are safety netted. Well, I suppose that was 2 unless I hit the insta-kills, so chances are that applies here as well. So I probably... Oh, wait. Safety net. So I probably want to not do a 2-stud climb up, because then I'd hit that neon, which is presumably an insta-kill, which would send me all the way back to the start. Am I? I don't think I'm able to... Am I? To ladder flick off that? Maybe I don't need to. Yeah, I can just do that. So now I don't have to do that again unless I hit an insta-kill. Alright, let's see what's going on here. Oh, that's another of those ice conveyors. Okay, I'm gonna go on this side because I have a bit more of space to land on. Thankfully, it's safety netted. You know, it's also true, even though there's these safety nets, which makes the stage not feel quite as long, it does mean it's a lot to redo if I get the math wrong. There we go. Now, avoid that insta-kill. So wrap around on this side, and that's gonna launch me over there, so let me face towards... that was close. Yeah, it's basically going to be impossible to reposition myself on this, so just hope. There we go. Again, avoid those insta-kills. Am I close? I think so. Okay, given that parabola, how many lines passing through bleh are tangent to bleh? Alright, Desmo's graphing calculator, my beloved. So it's asking how many lines passing through that are tangent to the parabola. This is kind of actually calculus, because a line tangent to the parabola is, say this. You can see it like crosses it exactly. Now that's at the... What is that called? But it could also be like a line going straight through here. So how many lines tangent to the parabola pass through this? I think it's going to be none, because any line tangent to the parabola is going to be... I mean, it's pretty much a straight line around this area, so no way is it going to be able to hit that point. Like, the tangent parabola never goes, like, inside the parabola. So it should be 0. Nice. One more stage is all that remains. Good, we had a sort of easier one on that penultimate stage, but that is a bit concerning in that it's going to be just something crazy hard as the math question on the very end. But maybe, just maybe, it will be find the some calculus question I know how to do. Hopefully something easy, like find the derivative of a polynomial function. Then again, it has been like 2 months now since I finished the calculus class, so... Hopefully I didn't forget everything, but my pages and pages of notes will surely be sufficient if I need it. Come on, Right, the obby is going to be really hard too, isn't it? And really long, because it's like the big tower at the end. So now what, do I... Okay, why did that like barely move me the first time? I guess I had to jump. Now, okay, I will hit that, the insta-kill. So what if I jump from down here? Yeah. If I effectively wrap around that, that's pretty easy. Now, let's see. I'm going to go on this side while being careful not to get physicsed. As in, hope I don't get physicsed, because it's so RNG. You know how ladders are. That thing's going to teleport me, so I'm going to want to jump to it and then quickly turn to go onto the truss. What did I just hit? Come on. So this thing is going to teleport me over there, then it's going to launch me to there, and then start spinning me around in a particle accelerator. Now, I don't know how fast it goes, or if it's going to start accelerating me. I guess it probably will hit a limit, and then that limit is most likely the speed I want to be at when I jump. Okay, that's not too bad. Nice. Are you kidding me? So apparently that first one just doesn't launch you at all, and there was no way I was able to know that. That's why I just moved out of the way. Okay, now that I see this, yeah, I probably do want to launch myself to there. Couldn't really see it from as good an angle before, as long as I just don't move once I start getting launched by it. Okay, now this is an ice conveyor, so I can sort of just jump on it normally. I see. So I'm gonna want to find like the sweet spot of where to jump from, which is not that. There we go. We love RNG conveyors. And that was actually the last, like, hard obstacle of this. What is the amplitude of the following function? And that is a very easy question. I will have to look up a refresher of what amplitude means. I think it's either here to here or here to here. Yes, it's the midline to the top. Now, unless this has had a vertical shift, which I don't think it has. Well, let's see. This goes up to 9. This goes down to -9. So yes, the x-axis is indeed the midline. Thus, the amplitude is it not exactly 9? It is not, because 9 isn't one of these answer choices. But what I can do is similar to what I was doing before. Just do 2 square root 3, 4 square root 5, and just see which of those is approximately 8.94, which would be this one, 4 square root 5. And there we go. Nice. That's it. That's math DCO for you. You don't seem savvy, do ya? Well, there's a bit more in store for you. Daily math problems, badge hunting, speedrunning. Well, there you have it. That is math difficulty chart obby complete. I can't thank everyone enough for all the support on the previous video, and if more stages of this get added, I guess I can play them. Let me know if you want to see that. Again, you can submit video ideas in the comments or in the Discord, link in the description. Be that other games I should play, or if I should maybe speedrun this or something, anything like that. So with that, I will see you in the next video, and have a great day.